and just want to check whether you can hear me or not. Maybe can you type in the Zoom chat? All right. Okay, I will get started. Good morning, everyone. Welcome everyone to Fit 2107 software quality and testing, and this is week 6 now. Time flies very fast, and today we're gonna cover on the topic about white box testing. Previously, we talked about the black box testing already, and now we're gonna talk about the white box testing and why it is so important and why do we need that. Okay, so the topics that we are going to cover today are these 4 topics. Okay, statement coverage, branch coverage, condition coverage, and modified condition and decision coverage. And why do we need that? Okay, we're gonna go through it. Okay. Yep. So by the end of today, by the end of this week, you will learn what is the basic fundamentals of the white box testing. There are different types of the code coverage measures like statement coverage, branch coverage, condition coverage, and modified condition decision coverage, or people call MCDC. And yeah, so we will test that. We will try this kind of measures during the studio, weekly studio as well. So previously we talked about 2 types of the testing strategies, right? In general, a high level idea, there are black box and the white box testing. Okay, so black box, basically we don't have access to the source code at all. Normally the knowledge source that we are knowing is the requirement, the specification, the domain knowledge, right? And we talk about some of these methods before. For example, equivalent class partitioning, boundary value analysis, and the category partitioning. So basically, when we design the test case, we just read the specification and come up with the test case. We don't need to look at the code, whether there's a branch or not, that kind of thing. But sometimes when we come up with the test case using the black box testing, right? We capture all of the possible requirements, but sometimes it doesn't mean that it achieves the highest coverage in terms of the code structure, code graph, or that kind of thing as well. If the code has like too many if else branch, that kind of thing, then the test case may not exercise every possible branches. So that's why white box testing is quite important, and we're gonna talk about how to design the test case that capture in a more fine-grained coverage measure as well. Okay. Yeah, so basically white box, okay, this is by definition, it is a software testing methodology that focus on examining the internal logic or the structure of the source code. We look at the if else, we look at the condition, Boolean expression, that kind of thing. So yeah, and with the black box testing, we don't have access to that, right? So when we design the test case, we don't know how many Boolean expression are there, and then how can we design the test cases to achieve everything, achieve the highest coverage. And this is more like the granularity level of each of the for each of the coverage measure. We what we try in the assignment task 3 or in the week 3 about unit testing is called code coverage, right? Or the statement coverage. So it measures how many lines of code that are executed by the test case. Okay, that's the line coverage. It is the coverage measure at the line level. But what we are going to talk about in the white box testing is that in a more detailed coverage measure, like branch decision coverage, condition coverage, path coverage, code psychometric complexity, or MCDC. Let's talk about some terminologies a little bit, right? What is some of you may have a question like what is the difference between branch, decision, or the condition? All right. So when we talk about the statement or line, it's just one execution line, that kind of thing. That one line that can one line of code that can be executed. But when we talk about the branch or the decision, it's a if else or switch statement, that kind of thing. Anything that the outcome becomes true or false is called branch or decision. Okay, so like in this case, if else, it has two branch, right? This is the if statement. Okay, something, yeah, and there are two branch here, either true or false. Okay, but anything inside the if statement is called condition. For example, A or B and C, that kind of thing. This is more like a complex uh, conditions now. It's called compound conditions. There are so many conditions inside the branch. Okay, when there are too many conditions here, right? So it affects the final outcome of the decision of the if statement. For example, if A or B and C, so we need to use the truth table to understand as well. We will talk about that in the later slide as well. Okay. Yeah. So that's a basic terminology. Just want to make sure that everyone understand this before we move to the next slide. Okay, and this is the basic one. We use this one in the Python code coverage before, coverage.py. We talk about this in the week 3 unit testing. We use this one in assignment 1 task 3 as well, the unit testing one. So just the basic code coverage, right? The line coverage. Like this one, this program, right? The goal is to print whether A plus B is positive or negative. This is the code, okay? A plus B is either positive or negative and print the outcome here. And let's say if we gonna input A equal -3 and B equal -9, like this, and the results will be negative, right? So in this case, how many lines of code that are executed, that are exercised by by this test case? Probably 6, right? So 6, because and in total there are 7, so we achieve only 85% code coverage, okay, line coverage here, because if we test based on the requirement, right, and then we probably miss some of these lines as well that we didn't test. Okay, so what we mean is that when we achieve high statement coverage, here doesn't guarantee the absence of software defects because we didn't test this part, right? That's why we need to look into the branch as well in a more detail. That's why people propose this kind of approach, branch or decision code coverage. And when we talk about branch, it means that it is the if-else statement, conditional loop, or switch as well. Conditional loop means while true, that kind of thing. Because in the while statement, there's a Boolean expression as well. Yeah. And when we talk about this, so we're gonna look at so the branch coverage measures what are the branches that are covered by the total numbers of branches, and we compute into the percentage, right? And let's take a look at this example together. All right. Okay. Click. Yep. So let's say let's take a look at this code. I create this example to illustrate the importance of the branch coverage and what is that and how to measure. So let's say if A equal to true, if A is true, B is true, it returns true, otherwise false. Okay. So if this is a test case, if we input A equal true, B is true, then what is the branch coverage, right? Based on this code, we understand the internal structure of the code, and then we're gonna draw the tree, okay, the branch tree. Let's say if this is the tree that we do, right? We have A equal to true here. Okay, no, sorry. We have how many branches that we have here? It should be okay. There are the first line here. There are 4 branches, right? When we talk about branches, it's the individual branches. That means how can I say? Within this code, there are 2 if statements. Each of the if statement consists of 2 branches, either true or false. That's why in total there are 4 branches. Okay. So what does it mean by 4 branches? The first one is A equal false. The second one, A equal true, B equal false, and B equal true. There are 4 branches. And when we test, if this is a test case, okay, A equal true, B equal true, That means we test only this branch, okay, 50% of them. But what is missing? A equal false and B equal false. They are not tested yet, okay? Yeah. So the statement coverage here in this case, right? If we say true, true, we can test line 1, 2, 3, 4, but line 5 is missing. All right. And that means what is the code coverage here? 80%, right? Statement coverage, 80%. But for the branch coverage, what is that? There are 4 branches in total. We test only A equal true, B equal true. So it is missing 2 branches. And the missing branches are A equal false and the B equal false, right? Okay. And that means if we use if we calculate by hand, this is what we are doing, right? But let's say if we use the coverage.py here to run to generate the code coverage of the test case that we have, what you need to do is to add the option dash branch here, right, into the command, and then it will add 2 more columns here and tell you which line or which branches are missing as well. Okay. In this case, because the coverage.py, when we have the branch option to consider the branch coverage as well, the percentage of the the coverage percentage here, it combines both branches and the statement together. Okay, so that means in total here we have how many lines? There are 5 lines. How many branches? There are 4 branches in total. So what do we mean is that we should achieve all of them, right? So 9 in total. But what we actually achieve is that we can cover only 4 lines and the 2 partial branches. Draw, yeah. So only 4 lines. These 4 lines, 1, 2, 3, 4, and the 2 partial branches, they are missing, right? A equal false, B equal false. This is a missing one. All right. So that's why we can achieve only 67%. Okay. Does it make sense? We are not, we do not achieve 100% yet. Okay. There's one question. Are the 4 branches include A, B, true, true, false, true, true, false, false, false? This is a very confusing part, but I would say that we should not consider that like that. Okay. We should look at the branch individually. Yeah, it's not the truth table at all. Okay, otherwise we will get confused. So we should look at individual branch. What I mean is that if there are 2 if statements here, one if statement have an option to be true or false. Okay, sorry, not option, the outcome to be true or false. So in this case, there are 4. If there are 3 if statements, the outcome will be 6. If there are 4 nested if statement, nested if statement, then the outcome will be 8. So sorry, and there are, I'm confused now. There are 8 branches in total. Okay, does that make sense? So it should not be a truth table. Yeah. Okay, that's right. Thank you. And then the question is that because we achieve 67% coverage at the moment, right? What are the missing test cases that we should do? Yeah, what we should test. Right now, if we look at the tree here, right? What we test is just only this one. What is missing? This one and this one. Is that right? So what we should test is that A equal false and B can be anything, right? But I would say it can be false as well, because if A is false here, then it will jump to this line anyway. Okay, so A equal false, B equal false. That's the test case, the second one. And the third, this is the second test case, and the third test case should be A equal true and B equal false. Okay, A equal true and the B equal false. In this case, we will achieve, what is that? What was that 100% statement coverage and also 100% branch coverage as well, right? Okay, yeah. Okay, let's take a look. Next, what is next? Yeah. Okay, this is what I mean. Yeah, because this part is missing, so that's why we need to test this one. A equal false, B equal false, but in this case we achieve 100% line coverage already, but it does not imply that we achieve 100% branch coverage. All right, but if we can achieve 100% branch coverage, it implies that we will achieve 100% line coverage anyway. Okay, so that's the branch coverage. We still missing B equal false. That's why we need another test case, A equal true and B equal false, and then we will achieve total coverage as 100%. Okay. So in this case, do we need 4 test cases or not? No, we just need only three test cases to achieve 100% branch coverage and the line coverage. Okay, in the basic principles of the software testing, right? We want to design or create the test cases at the smallest number to achieve the highest code coverage. We should not like design test case to be redundant at all, right? Okay, so in this case, we need only 3. We don't need 4. We can save 1. Let's say this is a more complex example. Let's work on it together. Because in this case, how many if statement do we have? Okay, 3. We have 3 if statement. Each of the if statement has 2 outcomes, true or false. So 3 times 2 becomes 6. In total, we will have 6 branches. And then when we say individual branches, we don't call these are the branch, okay? But we look at it individually. Individually means that A equal false, A equal true, B equal false, B equal true, C equal false, C equal true. Okay, there are 6 in total. And then if we test, okay, how many test cases, or what we can do if we use the formula? I should say like this. Okay. Something new. Okay, this is a secret. I will update the slide later as well. I forget to mention this one. Okay. There are some formulas that we can try as well. I don't know whether it is true for all the time or not, but generally, what do we need is that for the nested if like this, right? In these scenarios, the numbers of test cases required to achieve 100% branch coverage is the numbers of branch point plus 1. Branch point means how many if statements. In this case, there are 2 if statements. Again, branch point, not numbers of branches. Okay. Branch point means the if statement, and one if statement has 2 branches, either true or false. All right. In this case, there are 2 if statements. So that means we have 2 branch point. 2 plus 1 equal 3. So that's why 3 is the minimum numbers of test cases required to achieve 100% branch coverage. And same to this one. How many branch point that we have here? 3. So how many test cases do we need at the minimum? Should be 4, right? Okay, 4. So what are they? We're gonna try it together. Okay. Clear the screen a little bit. If we draw, the easiest way to work out is to draw this kind of tree, right? And what do we need is that true to true. Okay, easy. And what else? A equal false, and the BC can be anything. A equal true, B equal false, true, false, and C can be anything. And A equal true, B equal true, and C equal false. Okay, there are 4 in total. Is that correct or not? Yeah. So these are the 4 test cases that we need to achieve 100% branch coverage, right? And no one knows. Probably you won't believe me, so that's why we need to test it out as well. Let's say we write a unit test here, and we're gonna test this one, right? True to true, true false, false, true true false, false false false, that kind of thing. Okay, And when we run the Python code coverage, then we will achieve 100%. Okay, is that clear, everyone? If yes, then say yes in the Zoom chat. Yeah. Can someone say yes? Then we can move on. Yes, thank you. Okay. All right. So this is the example too. There are 3 if conditions, right? But let's say if I make it more complex by adding the and or like a more Boolean expression. What is that? That kind of this one and or x or not, that kind of thing, right? As I mentioned before, when we talk about the branch coverage, right, we look at the if statement only. We don't care about whatever exists inside. Okay, so in this case, we consider both A and B together as one thing, right, as one outcome of this if statement. Okay, A equal true and B equal true. So the outcome of this if statement can be only 2 things. Okay, 2 outcomes, either true or false. That's it. So that's why when we have this kind of case, we can come up with 4 test case, the same one as the previous one, right? But what happened here is that because we want to force A equal, no, sorry, when we do like this, right? What is that? Let's test this one, right? A equal, sorry, there are 4 test cases here. We run the unit test, and then we also achieve 100% code coverage. Does that make sense in this case? Okay, I assume yes. And then, but when we achieve 100% branch coverage, it doesn't mean that we achieve 100% condition coverage. Okay, so because in this case, there are 2 draw. Okay, there are 2 conditions here, right? A and B. So that's why what we test is that I think I should move to the next slide. Okay. What does it mean by condition coverage, right? So condition coverage is the sorry. Normally when we talk about the branch, okay, branch or the decision, it is anything inside the Boolean, inside the if statement. And the Boolean expression here can have the compound conditions. And compound conditions is that when there are 0 or more Boolean operators here. And the Boolean operators are, for example, and, or, X, or not, that kind of thing, right? Then in this case, there are so many conditions now, okay? So that's why we need to look, we need to measure condition coverage as well. And it measures the percentage of the conditions within the Boolean expression that have been evaluated to both true or false, okay? So that means if we look at this one, right, we have, of course, we have 4 variables, A, B, X, and Y. But what are the conditions? Okay, what are the conditions? A greater than B and X less than Y. And this one, it has 2 outcomes, right? A is greater than B or not, true or false. And X is less than Y, true or false. So in total, how many condition outcomes do we have? 4, okay? This is 4 condition outcome that we need to test. Make sure that the test case exercise everything to achieve the outcome both true and false here. Okay, this is the goal. Okay, let's move to the next slide. Yeah, mouse. All right, so this is the same example, example 3. What happened is that when we have this code, okay, and when we have 4 test cases here, how many branches do we have? Okay, branch outcome, right? We have 6 branches, but how many conditions outcome do we have? Actually, A, because there are 4 conditions here, right? A, B, C, and D. Okay, so because we have so in this case we have 8 conditions outcome, and we have only 4 test cases here. In the 4 test case, B is asserted to be true only, right? We never assert as a false. So that's why the C and D, what is that? So C and D is rich all the time, right? Because this is true. What is missing is that because in total there are 8 condition outcomes here, okay? This is A. And everything, this is a variable A, this is B, and this is C, and this is D. Both everything A, C, and D is asserted to be true and false, true and false, true and false, except B, right? B is asserted to be true only, except B is equal false. So that's why we achieve only 7 but divide by 8 here, which is 87.5% condition coverage, not 100% condition coverage. Does that make sense, everyone? So in this case, we achieve 100% branch coverage, but we do not achieve 100% condition coverage. Okay, makes sense because B is not asserted to be false. Yes? Yes or no? Can someone say something in the Zoom chat? Yes, okay. All right, thank you. Yeah, so in this case, what do we need? We need to come up with more test cases, right? To ensure that we achieve 100% branch coverage. But can someone help me? What is this test case then? We just come up with another one, right? Self anything, and then this one, let's say false. Probably I would say false, false, false here, and the outcome will be false. Then we will achieve 100% branch coverage. Okay, does that make sense? This is how can we address this problem. Okay, yeah. What about if condition with and or? Okay, in this case, this is the if condition. We have A or B and C. All right, and okay, how many conditions do how many branches do we have here? We have only 2. One if statement, 2 branch outcome, right? Either true or false here. Okay, and the whole thing is considered as 1 branch, 1 decision point. Okay, how many conditions, how many condition outcomes? We have 3 variables here. Okay, 3 variables, 3 conditions, A, B, and C. In total, we will have 6 condition outcome. 6 condition outcome. Each of them is true or false. Okay. If we have test case 1, TC1 here, and if we test A true, B true, C true, what is the branch coverage and the condition coverage, right? A true, B true, C true. There are total in this case there are 2 branches in total. So we this test case go to this part, okay, this branch. So we achieve only 50% code 50% branch coverage. Okay, 1 divided by 2. Okay, what about the condition? Condition, there are 6 in total. 6 in total. A should be asserted as both true false, B should be asserted as true false, C should be true false, but in this case we assert only true to true. Okay, so that means we achieve only 50%. Okay, only 3 of them. That means A equal 4, B equal 4, and C equal 4. We never assert that one. Okay, that's why in this case, with this test case, we achieve 50% branch coverage and 50% condition coverage. If we come up with another test case here, TC2, then we will achieve, if we test everything, right, for, then we will get 100% branch coverage because we will go to this branch now. The outcome will result to this branch. And we will also achieve 100% condition coverage as well because everything is asserted as false, everything is asserted as true. So in this case, we need two test cases to achieve what is that 100% condition and the branch coverage. Does that make sense? Okay. Let me know if you have any questions. And this is another example, hello or hi. If A is greater than 10, B is greater than 20, then say hello, otherwise hi. So in this case, how many branches? One if statement, one branch, and two branch outcome. Okay, so these are two branches. Okay. How many conditions? We have condition A, condition B here. Okay, A and B, and each of them has two outcomes. So there are four condition outcomes in total. For the first test case one, right? A true, false. Okay, what is that? True. A greater than 10. B, it is false. So test high. Okay. For the first test case, this is another false true. Then test high again. Okay. So what is the coverage for T1 and T2? Yeah. In this case, let's say branch. Okay. Branch condition. Can someone help me work together? Yeah. We have two branch here. Okay. In this case, we never say hello at all. So we achieve only 50%. All right. Condition, there are four outcomes. We assert A as true. This is false. This is false true. So we achieve everything. We test everything. All right. In this case, we achieve 100% condition coverage, but just only 50% branch coverage. So there's no dependency at all between branch and the condition. All right. Make sense, everyone? Okay. Why do we have two branches instead of three as before? Why do we have branches two instead of three? So in this case, I would say that this is the branch outcome. When we say three means the numbers of test cases required to achieve 100% branch coverage. Okay. So in this case, how many branch statement do we have? One. Okay, one. And then the minimum test cases required to achieve 100% branch coverage is two. Okay, we need two test cases, but these are not the right two test cases to achieve 100% branch coverage. So that's why we achieve only 50%. How is condition coverage 100%? Because in this case, okay, maybe I should rephrase everything again, okay? All right. In this case, we have one if statement. One if statement has two branches, right? So if we draw the same one as before, A is greater than 10 and the B is greater than 20, and we have two branches, false and true. Okay, this is not the right figure, I would say. This is more like a condition. Okay, we forget about it. Okay, so that's why we have two branches here. All right, but in terms of the condition, this is more like a condition graph. So condition, we have two outcomes for two conditions, right? We have two conditions here, A greater than 10, B greater than 20. Each of them has two outcomes. So we have four condition outcomes. Make sense? Is that clear? Why do we get 100% condition coverage here? Because for both test case here, for the first condition here is asserted to be both true and false. And the last one is asserted to be true and false as well. So we assert every possible condition outcomes, right? So that's why condition coverage is 100%. But the outcome for this two test case, right? It end up with false only for the if statement. In this case, we never print hello at all. So that's why we achieve only 50% branch coverage. Okay, does that make sense? Okay, where does the branch point plus one come in? Branch point means, in this case, it is applicable as well. Branch point means the numbers of if statement, not the numbers of branches. Okay. In this case, we have one if statement. Okay. And then the numbers of test cases required is 1 plus 1 equal 2. 2 is the minimum numbers of test cases required, but these are not the right two test cases to achieve 100% branch coverage. But let's say if we want to come up with the right one, everything to achieve both 100% branch coverage and 100% condition coverage, how many we should get, right? Okay, let's work on it together. T1, okay, branch should exit as true and false, right? So let's say true and true, and the false and the false. That means if this is what we want, that means A should be, let's say, 20, okay? A 20, B should be 30, all right? False, A can be 10, B should be 20, okay? In this case, what is the branch coverage? Okay, two test case here. In this case, what is that branch coverage? 100%, right? Okay, 100%. What about condition coverage? Also 100%. Does that make sense? Because this is true, false, and the true, false, and the outcome here is true, and the outcome here is false. So we achieve, 100% here, branch coverage, and this is the condition coverage. Does that make sense? I believe it makes sense. Yes. Okay. Thank you. All right. Okay. This is what I mean. Something is missing, right? This is not tested at all. Yeah. So, yeah, that's all. I think let's move to the example 6 here. This is an absolute number. Okay. Absolute function. If x is greater than 1, it should return x, otherwise dash x, minus x, okay? Let's say if we come up with two test cases here. Minus 2, absolute number of the minus 2, it should return 2. Absolute numbers of 2, it should return 2, okay? If we input minus 2 into this one, into this program, it will go to here, okay? Minus 2, then it return 2, okay? If we put 2, okay, it will go to here, it will return 2 as well. Looks like we achieve 100% coverage. Okay, looks good. What about branch coverage? Yes, probably yes as well, right? Yeah, 100% line coverage, 100% branch coverage. There's no condition here, so that's totally fine. But is this program correct? We test everything, we achieve 100% code coverage, but it doesn't mean that the program is correct, right? Let's try absolute 1. In reality, absolute 1, it should return 1, right? It should return 1. But if we put 1 here into here, okay, it will return minus 1, okay? The program is wrong, okay? So that's why when we use the branch coverage statement coverage, looks like we test everything. What I mean is that it only shows how many lines, how many branches that are exercised by the test case, but it doesn't mean that it doesn't prove the absence of software defects, right? So in this case, probably you should combine with the boundary value analysis technique together as well, because if we look at the domain input here, right? Absolute number, what is the boundary value? Okay, let's use the previous knowledge, right? The knowledge from the previous lecture. The boundary value here should be 0. So what should we test? Minus 1 and 1, right? That's more like an effective test cases rather than minus 2 and 2 here, okay? And so yeah, so in this case, 100% code coverage does not guarantee that the program is correct. That's why the correct implementation here should be x is greater than or equal 0, and this is the right one, right? When we missing -1 and 1 or 0 here, we may miss we may not test the program correctly as well. That's what I mean. All right. Okay. Another example, and, right? We have only one if statement. Okay. How many branch outcome do we have? Two, either true or false. How many condition coverage? How many condition outcomes in total? Should be 6 because we have 3 conditions here, A, B, and C. Each of them has 2 outcomes, true or false. In total, 2 times 3 equals 6. The goal is that we want to achieve 100% condition coverage. So A, B, C should be tested as true or false. And we would like to achieve 100% branch coverage as well. So that means it should return, the if statement should return either true or false, right? Okay, what is the optimal what is the optimized test case? How can we decide the test cases that are the most efficient? Okay, so what do we need here to achieve condition coverage, right? So that means everything should be tested as true or false. We just come up with true to true or false for false. We will get 100% condition coverage anyway. Make sense? What about the branch coverage here? Because this is an operator, right? Probably, I guess we should achieve 100% branch coverage as well. Yeah, that's the 100% branch coverage. And we also achieve 100% statement coverage as well. So these two test cases are very optimal, right? We test everything. Make sense? Instead of the other test cases like true to true, no, sorry, true to false, 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 true, that kind of thing. All right, okay. Now I'm gonna move to the last concept today, which is called MCDC, the most difficult one. MCDC is the technique to reduce the numbers of test cases to achieve the highest modified condition and the decision coverage. MCDC, this one. Okay, and what does it mean? Normally, actually, it should come from this slide first. Why MCDC is used? Okay, normally it is required for software developed at the highest critical level, like let's say NASA rocket system, that kind of thing. Boeing airplane as well. We want to ensure that all of the conditions in the if-else statement are well tested. Okay. Think about let me try to come up with an example. Okay, so let's say this is a rocket, right? The rocket can be launched if and only if the pilot is in the astronaut is in the rocket, the fuel is full, the system, let's say X numbers of system are ready, that kind of thing. So what I mean is that when we launch, when we want to launch a rocket here, there are so many conditions in order to before they make a decision, before the rocket can be launched, right? So that's why when there are lots of conditions here, it can be like a conditions explosion as well. We cannot test everything. So how can we systematically identify the minimal numbers of test cases to achieve the highest MCDC coverage? Okay, so that's why this is why we need it, because we cannot test everything. And yeah, so how to do? Okay, let's go to how to do together. What these are the principles that we should let me think. Okay, these are the principles. Okay, let's go through it together as well. First, the first principle is that the each entry and the exit point is invoked. Each decision takes every possible outcome. Each condition in a decision takes every possible outcome. Each condition in a decision is shown independently affect the outcome in the decision. I think I should go to the example. Okay. Let's say this is the same example. Okay. This is an admission method, and we only allow a student to be admitted if they have high degrees. Okay, they finish higher degrees, and either it should be character and degree or experience, right? Okay, they should well behave, they have a good character, okay, good guys, and they should have either high degrees or high experience. Okay, this is and then that student will get admitted, otherwise the application will be rejected. Okay, so how should we test this one? Whether the applicant, so in this case, how many conditions do we have? Three. Okay, three conditions: character, degree, and experience. And if we use the condition coverage, right, how many condition outcomes do we have? Six condition outcome from the three conditions here. Each of them has two outcomes, true or false. So we have six condition outcome. How can we decide the most effective test cases to achieve the 100% condition coverage? Okay. Yeah. And MCDC as well, modified condition. What does it mean, right? So if we don't reduce it, normally what we should test is that 8 combinations here, 8 test cases, right? And it's too much. Why do we need to test everything? Because some of them, they are redundant, right? And this is the systematic way, the technique to reduce the numbers of test cases, okay? The key goal is that for each condition, let's try to work on it together. For each condition, okay, let's start with the character. We want to find 2 test cases such that the condition cover both true and false. And while the other conditions are the same, but it changed the decision outcome. This is the decision outcome. Okay, what is that? We want to find the 2 test cases. Okay, first, true, everything. This is the first test case that we want to choose. The other one, the condition here, cover both true and false. So there's nothing can be this one. It can be any of this. But the other conditions must remain the same. It should be true too. Okay, this one. And the decision should be flipped as well. Okay, it changed the decision outcome. Okay, so in this case, we're gonna choose 1 and 5 as a potential test cases to achieve. What is that? Modify condition and the decision coverage, right? Modify condition, this one is modified, right? It's flipped, it's test both true and false, where the decision outcome is also covered true and false as well. So that's why in this case we have 1, 5 as one potential. Okay, not finished yet. Look at the next one. Okay, look at the next one. We already get this one. Let's take a look at the test case number 2, right? And find another test case, okay, such that the condition cover true and false. The others are the same, but the decision is flipped. Okay, true. Okay, not any of this anyway. Degree and experience should be the same. It should be this. Okay, true and false, true and false. And the character is flipped as well, and the decision is flipped. So we will have 2 and 6 as another potential test cases. Okay, let's take a look at the next one. 3. Okay, 3. We want to find, yeah, another test case. Okay, probably it should be 7. The character is flipped. The degree and experience, they are the same, remain the same, but the decision is flipped. Okay, So 3 and 7 is another potential potential test cases. Okay. All right. Now let's take a look at 4. This one. Okay. 4, the decision, the degree remain the same, which is good. The character, okay, this one, the condition is flipped. However, the decision is not flipped. So in this case, it is redundant. We don't need it at all. Okay, it is not a good test case to test, because no matter what we input here, okay, the outcome is the same. Okay, false and false. So we don't need that. We will not consider. Okay, now let's take a look at the degree, the next one, right? Degree. We want to, let's take a look at the number 1 here. Degree should be flipped. Character and experience should be the same, and the decision should be flipped as well. Do we have any? Let's find the character true and the experience true first. We have this, just only this one, but the decision is not flipped. Okay, degree is flipped, but the decision is not flipped, so we cannot do that. Okay, 1, 3 is not a good one. So let's move to the next one. 2. Okay, 2, number 2, test case number 2. The degree should be flipped, but the character and the experience should be the same. Okay, so let's find character and experience true, false. True, false, this one. Okay, true, false, and the degree should be flipped. Okay, and the decision outcome should be flipped as well. So 2, 4 is a good one. We're gonna keep it. What else? Number 3, 4, do we have or not? Is it good? Probably the rest we cannot, is not good anyway, because the decision is not flipped. I know that. Let's move to the experience. Experience, let's start with 3. Okay, 3. 3. Experience is true, so we want to find another one that the experience is false. Okay, it's flipped, but the character and the degrees are the same. Okay, should be this one. All right, and the decision is flipped as well. So 3, 4 is a good test case. So in total, what are the potential candidates for the test case? For the test case here, right? So for the character, we have 1, 5, 2, 6, 3, 7, degree 2, 4, 3, 4, this one. If we want to find the minimum numbers of test cases to achieve modify condition and the decision coverage, right? So what we should do, we just find the common one. Okay, so we have 4 here. Okay, we're gonna get 4, and because we're gonna choose these 2, this is what we need anyway. So we need to get 2, 3, 4. Okay, 2, 3, 4. All right, and 2, 3, 4, and because 2 appears here as well, we can choose 2, 3, 4, 6. Okay, if we choose 2, 3, 4, 6, we will achieve 100% MCDC. Does that make sense? MCDC means that the character is test both true and false. Degree is test true and false. Experience is test true and false. And the decision outcome becomes true and false as well. That's very optimal. Yeah. Wait, how are you ignoring 7 and 1? Yes, actually, 2, 3, 4, 6 is not the only option. We can also do 2, 3, 4, 7 as well. That's also another potential candidate. But what we cannot do is 1, 5. If we choose the 1, 5 here, what do we need? 1, 2, 3, 4, 5. So that's a 5 test cases. It's not the smallest number, right? So in this case, we can choose either 2, 3, 4, 6 or, okay, 2, 3, 4, 7. So we need 4 test cases to achieve the 100%, 100%, what is that? MCDC coverage. And another question can we do 1, 2, 3, 4, right? Let's work on it together. 1, 2, 3, 4, unlikely not, because if you choose 1 here, you need to go with the 5, and this is a 2, 2, 3, 4. That's why when you choose 1, 2, 3, 4, you need to go with the 5 as well. Otherwise, something is missing there, right? The decision is not flipped here. Yeah, it has to be coupled. Yes, yeah. That's right. Okay. So in this case, it can be 2, 3, 4, 2, 3, 4, 6, or 2, 3, 4, 7. And then we will achieve 100% MCDC. Okay. Easy like that. Is that clear to everyone? Yeah. And if we look at this one, right? No, this is just the decision table. So we don't need to talk about this at all. Okay. So what do we need? 2, 3, 4, 6. What is that? 2. We need only 4 test cases. 2, 3, 4. Okay. 6 here. All right. And character is test twice. Okay. No, sorry. Is test as true and false. Okay. True and false. Degree. True and false. Yeah. And experience is true and false. And this the decision also both true and false as well. Yeah. Yep, all good. That's all. Okay, surprisingly, I complete the lecture within 1 hour. This is the most difficult concept, right? And then, yeah, try to understand this one really well. It will appear in the assignment as well. Just a summary. Today we talk about the statement coverage, the line coverage, the branch coverage, decision coverage, condition coverage, and also MCDC. We need MCDC in the highly critical software system, for example, rocket, airplane, that kind of thing. Okay, we cannot miss any of them. And that's all for today. Next week, we will talk about the part coverage, psychometric complexity, control flow graph as well. Okay. All right. Any other questions or not? If not, then see you everyone in the workshop. Yeah, in the studio. Okay. Have a good day. Bye-bye.